So it's like when I give an example of the heater, you want the heat where the heater is. You see? More heater. Or maybe you want the heat where the fire is. That's where it's very hot. It's not far away from the fire. It's where it's found. You are in the location. You're not moving anywhere. Yes. Then we can also ask you, what is the heat 2 meters from the fire? The fire, it's there by the stove. You are standing by the door. Then I say, how much heat do you feel where you are standing at the door because of the stove? So you can say, oh, the fire is coming from there. It moved up to this point. So we want to know, mufutumalo, you are experiencing more emanating from Utswakwa. So there's a distance. Can you see? So which means this formula, it is still the same electric field by charge A, but not where A is. But there. I agree A will distribute the field. Yeah, I want you to understand that. So this is where this charge is at here. So which means if I were to use that formula, this one here, I will say electric field by A. You see, I'm using A, ne? Equals to the net, in other words, it will be the electric field, Yako A, divided by, let me use a capital letter, by charge of A. Is it making sense, right?
Yes, sir.
Yeah, it's this formula. Then you get the answer. We'll do that one. Then, if you have a charge A here, and then normally they will draw something like a distance, and they love to put a dot. Let that dot, I'm gonna call it B. It's a point. They also love to call it B. Now they say, what is the what is the electric field at P due to A, because of A? How much warmth does P feel because of the Q? Can you see now? We are not saying what is the electric field by P. No. What P is feeling because of Q. In other words, here we're saying what is the heat of A where A is. Now here we say what is the heat here at this point because of A. You get it? Yeah. So that will be that distance from afar. So again, that when you're doing the formula, it's going to be electric field. Again, it is by A. Can you see that? Yes. And then you're using Q, and then you'll use QA, and then you're using the distance, that distance which is from A to P. So this is the electric field that is felt by P because of A. That is at a distance. I wanted you to understand that. That's the thing. All right, now I can come back and explain the electric field now. The electric field, they say if you're dealing with a positive charge, the electric field, where does it go? Inward or away? Outwards, ne?
Yes, sir.
Yeah. I'm going to tell you how you can remember how they did it, these guys. How they did it. All right, and then they're going outward, the electric field. It pushes, the positive pushes away. Then, when you're using a negative one, they say when you're drawing electric field, they push inward. They are going inward. Electric field is going inward. So there we go. This is going inward. This is going inward. This is going inward. This is going inward. Now, I'm saying this in passing because most of the time they were supposed to ask this. Now, if I were to draw enough electric field, let's just draw many lines here. Let's just draw many lines like that. All right, there we go. Now, if you look at, and then there must be arrows, of course, pointing outward, and then outward. Now, I'm going to put a dot. What am I going to put?
A dot.
Say a dot. Okay, so here's a dot there. Now, this dot, if I bring it closer here, where we at here, let's squeeze it a little bit here, there. The electric field lines are more closer to each other. It's like they're squeezing one another. You know, it's like when you palaming the taxi, you're sitting back, say there's those big mamas. Hey, they squeeze you, like there's 3 of them. You are the 4th one. Hey, yeah. So they squeeze you. So there's too much force. So that means whenever a particle or closer to the charge, the electric field is stronger. Yeah. And then away, the squeeziness is less. The force or the electric field is less. Now, imagine, let me give you this. Always call it like this to help you. When they say electric field, you can call it the force field. Electric field, we are actually talking a force, a place where you experience a force. They call it, let's put it this way, a place where you experience a force by electric or electrons. They call it the electric field. But it's actually the force that can be found there in that place. You see? So I'm trying to make you understand that when we're saying field, we're talking about the force. It's the same thing. Yeah. So if we were to say the force that can be found there by Peter. You see, the force by who? By Peter. So they will call it Peter field. And then you're like, are we talking about Peter or force? You see, it's still the force. You get it?
Yes.
Yeah. So electric field and the force, they're not different. Okay. But we are just talking about, when you use that statement, we are saying an area, a space, a place where you can experience or feel a push or a pull. All right. So that was that story. So I'm not going to say much. That's all you need. So this is when you draw them separate. Then they give you something else in the next video.